In this lesson, we will be discussing heats of reaction and how they are determined in different reaction conditions. Heat of reaction refers to the amount of heat or energy that is either absorbed or released when a reaction takes place. When determining the heat of a reaction, we must begin by determining the conditions in which the reaction was carried out. That is, we need to know whether the reaction took place at a constant volume or at a constant pressure. Let's begin by looking at reactions that take place at a constant volume. In this case, the system may be a rigid vessel that can't change shape. So to begin determining how much heat is absorbed or released, let's take a look at the first law of thermodynamics. If we rearrange this equation to isolate Q, we can see that the transferred heat is equal to the change in internal energy plus the work done. However, since we know that the volume is constant, this means no work is done. This leaves us with the heat of reaction being equal to the change in internal energy. Now on to reactions taking place under constant pressure. In this case, the volume of the system may in fact change. Thus, we cannot disregard the work done on the system. To take work into account, we'll look at the concept of enthalpy. The enthalpy of a system is equal to the internal energy of a system and the product of its pressure and volume. This can be written as the following equation. H, which is the enthalpy of the system, is equal to U, the internal energy, plus pressure times volume. Let's now relate this enthalpy equation to the heat of a reaction. Firstly, we are not interested in the actual enthalpy of a system, as it's next to impossible to determine the exact internal energy of a system. Instead, we want to know the change in enthalpy. Thus, we'll update our equation to state that the change in enthalpy is equal to the change in internal energy plus the change in pressure times volume. Now, since we know our reaction will be taking place under constant pressure, we know that there will be no change in pressure, only in volume. Thus, we can also update our equation to show this. From here, we can substitute the internal energy with Q plus W from the first law of thermodynamics. We know that work is equal to negative P times the change in V, so we can substitute this in as well. We can see here that the negative P times the change in V and the positive P times the change in V cancel each other out. This finally leaves us with the heat of reaction being equal to the change in enthalpy. Let's quickly summarize what we've concluded. We've seen that at a constant volume, the heat of a reaction is equal to the internal energy change of the system. At constant pressure, on the other hand, the heat of a reaction is equal to the enthalpy change of a system. Most reactions take place at constant pressure, thus the change in enthalpy is the main focus for heats of reaction.